Hi everyone, we're going to be looking at doing a perspective match. So quite often what will happen is that we go out and take a photograph and then we want to try and render a 3D object and place it inside of that photograph, but to make it kind of look like it works, we have to try and mimic a similar type of perspective that the camera that took the original photograph had, and mimic that perspective in the Maya 3D camera. So there's a couple of ways that we can do this. There's the really quick and fast way where we're just eyeballing it, or there is the very sort of accurate where we use measurements and then try to get a very accurate representation, which is super important if you're trying to do like a architectural building replacement. You can't just eyeball it, whereas if it's something that's kind of looks right, then okay. So essentially what we need is the image in the viewport on an image plane, which is attached to your camera, your object, and then a ground plane which you can use to capture the shadows. Okay, so I'll just do a new scene. So to start with, what we need is a camera. So create a camera. Then we're going to go look through that camera. So we're going to go panels perspective camera 1. I'm just moving the camera a little bit. Okay. Now we're going to go and load our image plane. So view image plane, import image. Quite often these photographs are called backplates. Here I've got a few different images, and you'll see that there are certain sort of telltale lines that help describe the perspective of the lens of the camera that took it. So, okay, we have our image plane. Now, the thing about this is that the camera has got the image plane attached to it. So as the camera moves, the image plane moves with it. The only thing that really changes is where we are in the world. So you can see this grid here is moving up and down and stuff like that. So next step, we're going to do a ground plane, which is essentially just a plane. We start applying different objects to layers because keeping that in layers is really helpful. So this one's going to be a ground plane. Now that the ground plane is on a layer, you can toggle on and off the visibility or lock it so that it doesn't move. Now, the perspective that we were talking about is the photograph has got some horizontal lines. The idea of a camera match is to try and reposition the camera so that the lines start feeling like they are matching. So this line here is a good start, but then the line between the bottom of the tables looks like it would go this way, but you can see how that line does not line up with the grid, which is in this direction. It's slightly tilted. So one of the things that we would need to do is to also check the focal length or the millimeter lens that's on your Maya camera and try and match that to the lens that your current camera was using when it took the original photo. If you know that, you can go and set it, but if you don't know it, you're going to have to just try some things out. I took this on a mobile phone, so I've found that 20 is a fairly nice number. And the process here is going to be slowly trying to reposition the camera so that it's starting to match a little bit clearer. Another thing that I do was I was just rotating in this view, and that can be helpful. But another thing you can do is to go and try and move the camera in the viewport, and you may find that you're getting slightly easier to understand results. I've effectively got this line working between the two different concretes, and I've been aiming to try and get that line as close as possible. This is fairly good. It's at an acceptable stage. So then we're going to go and add our object. I created a text, and inside of the text you can change the number of extrude divisions under type extrude, how big, deep it goes, and if you need to change in the attribute editor, if you go to the type is when you can change the message. And font size. Now, one of the important things with camera matching is you've spent all this time trying to get the camera in the right place, you might accidentally move it. So select your transforms of your selected camera, right click and lock the selected. Now you cannot move or accidentally reposition and lose all of that hard work. If, on the other hand, you want to go and make some changes, you can always right click and unlock them at any time and then relock them later. I'm going to add a sky dome. Now we've got light, but we have no alpha channel, so we need to change a few little settings here. Number one is we're going to make the sky dome not visible in the renderer. So if you select your sky dome and then you go to your attributes, and a little bit further down inside of the sky dome attributes you'll see visibility camera. If we turn this off, it is now no longer visible to the camera, and we're getting a final look, RGB and an alpha channel, which is good. But we're not getting the shadow landing on the ground. So next we need to get our ground plane. We need to assign a new material to the ground plane. The type of material we're looking for is an Arnold shader called an AI shadow matte. Some of the other things that we would probably want to do is to put in a image or a HDRI on our sky dome. So select your sky dome, go to your attribute editor, and in the color slot go and find a file and go add find a map that feels similar to your background. So you can see our render with the backplate, but the idea is that you kind of don't want to have the backplate because it's interfering with our alpha channel, so that we can composite it later. So what we need to do is we need to now hide this image plane, and to select it you just have to select it in the viewport, and then in the attribute editor you will see that there is a display mode of the image plane, and at the moment it's set to RGB, so just set it to none, and what that'll do is it'll remove it from the render and it will allow you to have an alpha channel. Okay, so eventually you're going to get something like this, where you're starting to get a little bit of this white fuzzy halo on the floor, and that means that you're getting a shadow in your alpha channel, and when you go back to your color you don't see anything. So that's what the shadow matte does, is it captures the shadow of your image and allows you to then composite that into Photoshop. Just a second ago I was trying to figure out what was wrong, why it didn't work for me, so sometimes this happens. I just had to delete the plane and rebuild a new plane and reapply the shader, and then it started working. You'll notice that sometimes you're getting a lot of grain from your render settings, so the last little bit that we need to do is to create the same sized image, because this image is a certain resolution, and if you want to render something, if it's the same resolution, then the two pieces are going to land on top of each other perfectly. So let's go find the image properties, and in details it is 4160. So in the render settings, on the common, so just by going up to the same resolution of this image, you'll see that we're already getting a much better resolution of image, because there's far more pixels, but there's still quite a lot of grain. So there's a few other small things that we can change here. Some of the things that you can change are in the actual render settings, and some are in the light settings. So I'll just bring these up here so that we can see what they do. I like using this light listener, which is this button here, and what it allows you to do is to change some settings on the light specifically. For instance, one of the settings is samples, the number of samples that the sky dome has. So I'm going to set this to 3, and every time you do a change you'll see that the render updates. Now as the render goes through, you can see that it's a much cleaner finish. It's still slowing down because it's got far more samples to try and process. If this is not giving you enough resolution, you can go up, but so will your render time. Other things that you can change is your camera AA, going up to 4. That's kind of like a global sample setting, and other things like your diffuse and your specular, and perhaps your indirect. Transmission is more about light transmitting, and SSS is for subsurface scattering. With these settings going up, you can see that the render time is much slower. Eventually, it's going to be done. When you save your file, make sure that you save it as either a PNG or an EXR. Those have embedded alpha channels. And once you have that, open your backplate in Photoshop, bring in your image, and it should literally just land in exactly the same spot. If your render is a different resolution, it'll mean that your 3D is going to land in a different location.